Now let's start solving exercise 7.1. We'll solve the first question. In quadrilateral ACBD, ACBD is one quadrilateral where AC is equal to AD. So how will we denote this? We will denote this by one line. Okay, and AB is bisecting angle A, means bisecting means this angle and this angle are same, right? That is angle CAB and angle DAB are both equal. Here we have to show that triangle ABC is congruent to triangle ABD. And one more question is asked, what can you say about BC and BD, right? Is BC equal to BD? We have to show this also. How will we solve this? Whatever information is given, we'll write it down. In triangle ACB and triangle ADB, AC equal to AD. This is given, right? And here angle CAB equal to angle DAB, right? These both are equal because AB bisects angle A. So these both angles are equal, CAB and DAB. Now AB is common, right, for both these triangles ACB and ADB. Now we can say that triangle ABC is congruent to triangle ABD. Therefore you can say that BC equal to BD. Why you can say this? Because corresponding parts of congruent triangles are equal. Okay, now let's solve question number 4. What does it say? L and M are two lines parallel and they are intersected by another pair of parallel lines, namely P and Q, right? P is intersecting line L at A and P is intersecting line M at B. Same way Q is parallel to line P and it is intersecting line L at D and it is intersecting line M at C, right? P, Q are parallel and L and M are parallel, right? Now we have to show that triangle ABC is congruent to triangle CDA, right? So how will we prove this? First, what information is given? Angle BAC equal to angle ACD. These are alternate angles, right? We have learned in earlier chapter, alternate angles are equal. Okay, this angle BAC is equal to ACD, right? These two parallel lines, you remember, when they are joined, the alternate angles will be equal. Now AC is equal to AC, right? It is common. Why? It is common, right, for both these triangles ABC and ACD. Now angle BCA equal to angle DAC. How you can say that? They both are angle. They are also alternate angles, right? BAC, okay? BCA, this angle is congruent, is equal to CAD, right? Now you can say that triangle ABC is congruent to triangle CDA by angle side angle congruency rule, right? This angle, this side and this angle, okay? Two angles and one side are equal, so you can say that they are congruent to each other, right? Now let's solve question number 7. This AB is a line segment and P is its midpoint. That means distance AP is equal to distance PB, and D and E are points on the same side of AB. Both are on the same sides, such that BAD is equal to angle ABE and angle EPA is equal to angle DPB, right? These two angles are equal to each other and these two angles are equal to each other. We have to show that DAP is congruent to EBP, and we have to show that AD is equal to EB, right? How will we start? What information is given? First we will write that it is given angle EPA is equal to angle DPB, right? Now adding angle EPD on both sides, what we will get? We get angle EPA. You have to add this angle EPD, so write it down. Angle EPD, equal to sign will remain as it is, and angle DPB will remain as it is. You have to add EPD angle EPD on both sides, right? You remember Euclid's axiom, right? If equals are added to equals, the wholes are equal. So now when you add angle EPA and angle EPD, you will get angle APD. So this will become angle APD, and this angle, when you add DPB and angle EPD, you will get angle BPE. So you will write it down, angle BPE. So these both angles are equal, right? Now consider this triangle DAP and triangle EBP, right? In this, angle A is common to angle is equal to angle B, which is given. We'll write it down, right? In triangle DAP and triangle EBP, angle A is equal to angle B is given, and AP equal to PB, right? See here, AP equal to PB. This is also given since P is the midpoint of A and B, right? We'll write down the reason, because P is midpoint of line segment AB, angle APD equal to angle BPE. Right? We have proved this earlier. You can write it down. Proved above. Now hence you can write down triangle DAP is congruent to triangle EBP. By which rule you can say angle side angle congruency rule. It is proved. Okay. Now let's solve question number 8. In triangle ABC, it is a right triangle at C. Point C, the angle is 90 degrees. And M is midpoint of hypotenuse AB. Right? AB is the hypotenuse of triangle ABC. And it is produced further to a point D such that DM distance is equal to distance CM, right? And D is joined to point B, right? This figure is drawn for you. Okay. We have to prove that triangle AMC is congruent to triangle BMD. Second thing, we have to prove that angle DBC is a right angle and DBC is congruent to triangle ACB. And fourth thing, we have to prove that CM distance is equal to half of distance AB. Right? These four things we have to prove. Right? So how will we start? First of all, we will consider triangle AMC and triangle BMD. CM equal to DN. This is given, right? See, this CM distance is equal to DM. Sorry. This is given. Okay. Second thing will come AMC is equal to angle BMD. This angle AMC is equal to BMD. How you can say that they both are equal? Because of vertically opposite angles, right? So we will write it down. Now AM equal to MB. How we can say that they both are equal? Because M is the midpoint of AB. Right? M is midpoint of AB. So you can say that AM is equal to MB. Right? Hence we can say that triangle AMC is congruent to triangle DBM. You can say this because of side congruency rule. Right? First thing we have proved. Now second thing they have asked is We have to prove that angle DBC is a right angle triangle, this one. So for this we'll consider that triangle AMC is congruent to triangle DBM, which is proved. We'll make a mention of it. Triangle AMC is congruent to triangle DBM, which is proved above. With this we'll move ahead. Angle CAM is equal to angle DBM. CAM is equal to angle DBM. How you can say that? Because corresponding parts of congruent triangles are equal. You know that, right? So we'll make a note of it. Because corresponding parts of congruent triangles. You can write down CPCT. No need to write corresponding parts of congruent triangles whole. You can use this short form. Okay. Now, since alternate angles, angle CAM and angle DBM are equal, therefore you can say that this AC is parallel to BD, right? This CAM is equal to DBM, right? You know these corresponding angles and alternate angles, right? You know all these, we have studied in the earlier chapter. Therefore, AC will be parallel to BD, right? Now, angle ACB plus angle DBC equal to 180 degrees because they are interior angles. So their sum will be equal to 180 degrees. Okay. Now since the value of ACB is given, it is 90 degrees. It is a right angle triangle. So the measurement is 90 degrees plus angle DBC equal to 180. So when we solve this, we will get the value of angle DBC as 90 degrees. So the second part also we have proved. When it is 90 degrees, you can say that angle DBC is a right angle, right? Now let's prove part number 3. What it is asked to prove? Triangle DBC is congruent to triangle ACB. These both triangles are congruent to each other. So we will consider triangle ACB and triangle DBC, right? DBC and ACB, these two triangles will consider. In this, DB is equal to AC. These both distances are equal. Why we can say? Because of congruency of AMC triangle with triangle BMD, right? Now angle DBC is equal to angle ACB. We have proved this above. Right? Here we have proved this. Both are equal. And the third one is BC is common. Why? Because BC is common for both triangles, right? So you can say that hence triangle DBC is congruent to triangle ACB. We can say this by side angle. One was angle, so you can say this by side angle side congruency rule, right? There are two sides and one angle is there. Now the fourth part is remaining. We have to prove that this distance CM is half of distance AB, right? So how will we prove that? Let us see. CD is equal to AB, right? How we know that? These both are equal because we have proved earlier that triangle DBC is congruent to triangle ACB. Now we know that CM equal to DM, right? The distance of CM is equal to the distance of DM. Yeah, it is given, right? This is given, and these both are equal to half of CD, right? These both are equal to half of CD. MC and DM is equal to half of BC. So we'll write it down. CM equal to half of CD. Now you know that this CM equal to half of AB. Now CM will be equal to half of, in place of CD we will write AB, right? Since CD and AB are equal, so we can write that CM equal to half of AB. Thus we have proved that the CM is half of AB, right? So all these four questions we have proved, and we have completed exercise 7.1.